All right, so second talk I'm doing on my own now, I guess. I was hoping some folks here would have to do a KubeCon talk next week, so that's why we have it the week right before KubeCon. But doesn't seem like anyone is doing KubeCon talks right now. So we were missing one spot, so I'm filling in. But nonetheless, there's this funny new project that we started at Polar Signals, and it's quite nice and neat. So I think it should be a good talk nonetheless. So let's get right into it. So Kubezonnet and why does it matter? So let's first talk about same zone versus cross-zone traffic. So usually, if you look at cloud providers, you have regions. So the region would be Europe West 3 in this case, and then within the region you have zones, so A, B, C, and you can send traffic between between these zones. But if you send traffic between these zones, they are going to charge you for that traffic. So just something to be aware of. But yeah, generally speaking, you have regions, and then within those you have zones. And same zone, if your machines are in the same data center, basically, they don't charge you any money or anything for that traffic. But if you go between data centers, basically, they're going to start charging you. So I think this might be for GCP, but I think it's pretty similar on AWS, Azure, and a bunch of other cloud providers. There's also throughput limitations, so same zone is quite a lot faster compared to a cross zone, and then obviously latency as well, where you get way faster latencies in the same zone than cross zone. So being aware of this just helps you deliver more costly and more and more performant applications basically. So we want to do mostly same zone traffic because it's usually free, and we want to avoid cross-zone traffic because we have to usually pay it, and those costs can add up quickly. So just something to be aware of. And why do we at Polar Signals care about this, right? Why am I giving this talk basically? So if you look at our GCP bill, you can see why we care about this. And I heard from someone else, yeah, cross-zone traffic is quite a lot on our bill, just here 10 minutes ago. So I think something for everybody to look at their bills and see how much percentage-wise cross-zone traffic is taking up on your bills. Basically, at Polar Signals, what we do, we run agents. They're using eBPF. We are doing zero instrumentation, eBPF, continuous profiling. So basically what that means is 19 times per second, we look at what's running on your hosts, and we look at the stack traces. We collect basically statistical data of the processes running, and then we aggregate that data and we send it off to our cloud. So you can see basically the flame graphs that were mentioned in the previous talk. We do this using eBPF on all the time in production, and we do it with less than 1% overhead for the application itself, because we only do it 19 times per second. And all of these hosts run in various different customer premises, and they start sending their data to our Polar Signals cloud. And within that cloud, we basically have ingesters, and they fan out, and they send to different storage backends. And we had a lot of different pods basically within our Kubernetes cluster talking to each other. So that's why we had this cross-zone traffic showing up significantly in our cloud bill. So we wanted to improve that. We wanted to get those percentages down of the cross-zone traffic cost, and the first rule is we measure, right? We are at Prometheus meetup, so we always want to get some data, we always want to measure, and then we want to make informed decisions about the things we want to change. What does GCP give us, right? Can GCP give us more on which part is talking a lot to which other part? turns out this is as good as it gets with GCP. So super helpful. I don't know, maybe they have like some incentive to not like show to us more detailed, but that's what we get. We basically went to the internet and we're looking at different options. Can we get Cilium to give us more data in that sense, given that Cilium is our networking provider or overlay network on GKE on GCP. So many acronyms. Yeah, it turns out there are some ideas, and overall, none of them have been implemented. So maybe in the future, but for now, we had to resort to doing something different, which then became Kubezonnet. Kubezonnet is short for Kubernetes cross-zone network monitoring. I don't know. You can ask Frederick, our boss, who came up with this. Maybe it's an homage to JSONnet. Which potentially I might also mention later. Yeah, so how does Kubezonnet kind of like compose? So we have, again, an agent and we have a server component. So the agent actually runs on all nodes. I think we have I have something here. So basically on Kubernetes, we deploy a daemon set, and then on every node that we have, we run this agent, and we basically, using eBPF, we hook into the Linux kernel, and we basically filter for the packets in the network, and then we aggregate the traffic data by source IP and destination IP, and we sum up the amount of bytes that we are seeing for that pair. And then we take it, the aggregated data, and we send it over to the server. So we have one replica of the server component of Kubezonnet running in our cluster. And then those agents are basically, once they have gathered some data, they are going to send this data over to the centralized server. And the server component, this pod, this container, is going to talk to the Kubernetes API to figure out, okay, like, which pod does this IP belong to? And then it will figure out this pod belongs to, or is running on that node, and this node is in this zone. So basically, this is how we can like gather some more information about like the IPs in between, basically going from the IPs to the zones. So yeah, like just going a bit more into detail again, like basically have the tuples of source IP, destination IP, and then the over time aggregated for sometime the amount of bytes that were sent from that source IP to that destination IP. How does it work? I think this is as low as we going to get today. So we use eBPF again, and this is Go code. So essentially, from Go, we are attaching this filter using eBPF, or like attaching an eBPF filter into the networking stack. And the way this looks, so this is basically like roughly C code. And the most important part is, as you can see on line 41, we are calling the handle IP version 4 function. So we don't support IPv6 right now, but for IPv4, we go into the handle v4 function. And within that, we essentially extract from the packages the source IP, the destination IP on line 54 and 55, and then we sum up the value, so the value being the amount of bytes sent within that networking package. And I think we store it in the BPF map. So basically, like a key value pair, or like a map for that specific source IP, destination IP hash, so we can keep track of the same source to destination key pairs showing up, and then like basically aggregating the amount of bytes sent over time. And then from, I guess let's stay here for a bit, and then from the Go program, we just read those eBPF maps. So essentially, the Linux kernel will do this work with the C code in between every now and then it will write the results into the BPF map, And from the Go code from user space, we can read the same BPF maps and basically read the same memory from the kernel without basically going into like a syscall or anything. So we can just from user space get this information into our Go code. So, and from the Go code then like is kind of normal sending data over the wire through the network. Again, so this is kind of the same questions as earlier. We get an IP, and we want to figure out what pod does it belong to, on what node is it, and which zone is the node in. From that, we can already, in the server component, start logging the pods talking to the other pods in our network, and we can log how many bytes we've seen from one pod to that other pod over time. So this is pretty nice. You can already see some interesting things you might have not guessed or assumed. But I think the real deal is being able to then take a Prometheus and scrape the metrics. So the server component implements or has an /metrics endpoint, and Prometheus can go ahead and then scrape that server's metrics endpoint. So this is what we get. I guess, yeah, you can't really see the interesting labels, but there's like namespace labels, there's pod labels in the redacted area. And then we can get like the source and destination pod names and the amount of bytes sent from one pod to the other pod. And doing that, we can, like in this example, we didn't do a top K of the 20 highest, like per second bytes sent from a pod to another pod. So all of a sudden, we know over time which pod is talking to which other pod the most. So doing that, we were able to then figure out like which zones are talking to which zones using Prometheus metrics and implementing some changes in our infrastructure such that we were able to use some traffic routing to stay within the same zone, for example, and we got it down quite significantly such that I think our compute is by far the most expensive now, not the interzone traffic anymore. So yeah, I hope that like inspires some other folks in here to try the same. And then I think a quick story I want to tell is back in November, I think like all of the Kubezonnet stuff we already did like last summer, so in July. But flying over to Salt Lake City for KubeCon, I basically landed, and Frederick was like, our cross-zone traffic like increased quite a lot. You have to take a look into this. And I was like, okay, what am I gonna do? So basically, this is the story of it. So we had our Thanos setup, and our Thanos setup was we have like previously we were just like actually running Prometheus like 2 replicas, I think for like 3 years, which was totally fine. But I think some of our someone on our team was like, some incident is happening, whatever, like I need to get rid of this, and accidentally deleted the PVCs, so the volumes of Prometheus, and everything was gone. So that was pretty bad, and that's when we decided, okay, we're gonna sprinkle some Thanos on top of our Prometheus setup such that we can get the data offloaded into object storage. And pretty typical setup that we have, except like now my diagram shows the zones of where the pods are located and how they communicate, right? But this is like the reason, like, so like why we even set up Thanos in the first place. But we actually have been super successful just running 2 Prometheus replicas for like 3 years in production, and it worked great. So just want to highlight that. That's also totally fine to do. But yeah, here we are. We have a Thanos setup, and then basically we had Prometheus decreased its retention from, I think, 33 days down to 3 days. So the Prometheus only had 3 days of data on its disks. just to get it more lightweight, because we don't want to have like 30 days of data in Prometheus plus everything else in Thanos. So we wanted to take advantage of that. By doing that, we had to move some of our SLOs that were across like 4 weeks. We had to also move them from the Thanos rule, from the Prometheus into the Thanos ruler, just so that we could like actually query over like 4 weeks worth of data, because Prometheus only had 3 days left at that point. Yeah, so that was the setup that we had, and Frederick was like our like moving the Prometheus rules. So basically the SLOs from Prometheus to Thanos like quadrupled our cost with like cross-zone traffic. So I was like, okay, like let's investigate this. So again, we used Kubezonnet for the Thanos setup. So we set it up, and sure enough, we could see that the Thanos rule all of a sudden like evaluating a lot more rules, obviously, because we like basically I think 90% of our alerting rules and recording rules are SLO related. So we moved all of those from Prometheus to Thanos rule, and that component was just like actually doing a lot more work, requesting a lot more data from the Thanos query. And the Thanos query then was like, yep, I need to like query it from all of those other components, right? And they were then calling object storage. So like everything just like increased quite a lot. And in red here, we can now see all the cross-zone traffic that's happening in the setup. Yeah, so this is the JSONet part. So I don't know, it's a kind of like an insider joke, because I love JSONet. A lot of people don't like JSONet, but bear with me on this one. So basically, the deployments or the parts of like all of these components that we have here, we specified using JSONet instead of YAML. So we can do like if else statements, we can do for loops, etc. And it turns out that having this JSONet setup was pretty nice, because at the very top, we basically just defined the Thanos zones we wanted to deploy the components to, and then we used those zones and templated them into like selectors, such that a pod would only get scheduled onto nodes in a specific zone, for example. Yeah, and in the very bottom, you can see the for zone and Thanos zones. So essentially, this now duplicates or like copies a Thanos store pod that like previously only ran in one zone, and deploys it to like all 3 zones that we have. So that was pretty nice, kind of like a good side effect of having something where you can template the deployment more easily. Yeah, so in here I think I might have like thrown this like second one on top of the more important one. Did I? Yes. Let's actually remove this. Can I remove this? Move it around? Too bad. Seems like I don't have edit permissions on this machine. But yeah, like basically within every single service we have, we now specify the traffic policy to stay within a zone. So if a request comes and tries to get into like a pod where a service is in front of that pod, Kubernetes now makes sure that service is within the same zone. So it will like basically prefer like pods within the same zone using that option in the Kubernetes service, which unfortunately I can't show you now. But yeah, I can tweet it later, and then you can take a look. But that's basically, so like we replicated all the pods onto like every single zone. We said like this pod can only be scheduled into this zone, and the other pods into their respective zones. And then we said like if one pod talks to the other pod, they have to be in the same zone. So yeah, basically this happened. So going back, yeah, the Kubernetes 131 traffic distribution allowed us to like cut all the like interzone traffic. Unfortunately, we couldn't really get rid of like some of the cross-zone traffic because like the Thanos query still needs to talk to some like both Prometheus servers, for example, just to get the full picture. But it still drastically reduced the amount of traffic we had in our Thanos setup. Coming back to Kubezonnet, there's a lot more on the roadmap, which we might get to, but like for us it works. So if somebody needs to make it CNI, so like a different networking provider independent, feel free to approach us. If you need IPv6, there are ways to make that happen. So yeah, like overall contributions are welcome. If you go and like deploy the agents and the server components on your clusters and you run into problems there, please feel free to open issues and obviously pull requests. Shout outs to these lovely people, one of which is in the audience. But yeah, overall, it was something like we aren't networking experts, we do profiling. We know a bit of eBPF, but there were some amazing people out there we reached out to and they were a great help. And that's it. Thank you. Do you have questions? I'm happy to like dive into more of the eBPF or like something about like JSONnet. Yeah. More JSONnet. Yeah. Yeah, there's like the question was like Cilium needs to be in legacy mode. I actually should know about this, and Frederick told me, but I forgot. But Casey is here, so hi, Casey.
I work for Cilium. So you need to do host routing mode in this particular way they've implemented it, because otherwise Cilium will send the packets through BPF directly to the egress interface. So you don't have the opportunity to intercept it, unless you're very clever. But you know, that's fine. It doesn't have as much a performance penalty as you would think until you are doing crazy things.
But I think there are ways of like of improving the architecture to not have to run legacy mode, right?
Sure.
That's on the roadmap. So I know it's like generally speaking possible. But yeah, thank you for clearing that up. Any other questions? Yeah.
So you use Cilium, right? And I think Cilium also provides Hubble instrumentation. Is it possible to achieve the same result with Hubble metrics?
Yeah. So basically the question is like, can we do something with Cilium only? And I think this is kind of like going back to all of these issues we had on this slide. Where is it? Like I think some of this is behind that. So like if you go and read through these, you might find a. Okay. So yeah, Casey again. Yeah, doesn't do sizes, Hubble. Yeah.
Just does sends.
Okay, just how many packets there were?
Just
No? Okay. Okay. So who's talking to whom? Yeah. Okay. So I'm happy you joined, Casey. Okay. Aditya.
Now that you have the pod IP already, have you tried correlating that to other observability signals and like looking back into, let's say, in this case you had Thanos, which was like you were familiar with it. Like, have you tried it on an unknown system and try to figure out like what part of the code there is or what route is generating this traffic?
Yeah. Okay. So the question is, have we tried this with like unknown systems we're running? I mean, I don't know. We to some extent wrote Thanos, right? So we know Thanos pretty well. Like all the like super high traffic things we're running is like the actual service that we're building. So I guess the answer is no. We haven't tried it with like other like big systems, because like the big systems we run like we know super well. But like yeah, like generally speaking, it's a bunch of networking, bunch of metrics. So you can like throw it on any Kubernetes cluster. and start like seeing where inter-cross zone traffic is happening. Yeah, and like I don't know, like you could also like something that we actually did for the Thanos investigation was like we weren't actually running the Kubezonnet agent and server all the time, always on basically, but like just like we deployed, like Damon said, the deployment. We actually had Prometheus scrape it from the outside from our computers, like going into this, like did some investigations, and then that's how we decreased the bill. And like if the bill gets too big again, we might do the same. So you don't have to like run this like all the time, right? Like if somebody here like told me like, okay, I have like a super high bill in that regard, like you can like run it for like a week or two and then turn it off once you like reduce your bill and you actually see that like it decreased, right? So also an option.